Welcome everyone to the post-contest discussion of Codeforces round 895 for D3. I'll start with question A. Uh, Question is about two vessels. Uh, One of the vessel contains 8 gram of water and another contains 7 gram of water. And there is a cup that has the capacity of C grams. We can transfer uh, at most C grams of water at a time from any cup, any vessel to another vessel. So what happens is, let's look at the first discus. Okay. In this discus, there are 3 grams of water in a vessel and 7 grams of water in another vessel. And the cup can carry at most 2 gram of water. Okay. What we can do is, we can just transfer 2 gram of water from here to here. Then this will become 5. Let's make one note. Okay, let's see. The first vessel contains 3 gram of water at the beginning, and the second vessel contains the first vessel I'll denote by 1, and second vessel I'll denote by 2. The first vessel 3 and second vessel contains 7 grams of water at the beginning. What I'll do is, the cup can carry 2 gram of water. So I'll just transfer 2 gram of water from the second vessel to the first vessel. So the amount of water at the second vessel will be 5. Then the and 2 gram of water will get added to the first vessel, and the water in the first vessel will also be 5 after an operation. So this the minimum number of operation will be 1. We just transfer 2 gram of water from second vessel to the first vessel. And let's look at the second test case also. You can see that we can just transfer 4 grams of water 3 times. 3 grams of water 3 times from this vessel to this vessel. If I first it will become 17, then 17 and 4 at the beginning. After transferring for the first time, it will get to 14, and it will get to 7. And after the second operation, it will get to 13, and it will get to 10. And at the third operation, I'll just transfer 1.5 liters of water. It can be decimal. It will be like 11.5, and it will be 11.5. Now the amount of water at the both vessels are equal. The operations took us 3 operations. So what we can observe at the first beginning is that if we transfer the amount of water from the from the vessel that contains the more amount of water, the operations will be minimum. You can check for every cases. Like for this case, we will just transfer 50 times from this vessel to this vessel. The amount of water will be get equal. Okay. So what is the approach? For the approach, uh, uh, after all the operations, the amount of water should be equal. So both the vessels should contains the amount of water is should be sum divided by 2. After all the operations, both the vessel should contains sum divided by 2 amount of water. That is, for this case, 3 plus 7 by 2, that is 5 milliliter. For this case, 11.5, and for this case, 34 divided by 2, 17 only. That is here it is always equal. So what we can do is we can just subtract, like we can let's just check how many operations it took it takes from the like to go from the largest from the vessel to the that contains maximum number of water to like to the average, like for the highest, from the highest to sum divided by 2. Okay, it's just some it will just drags down to a formula. You can see what I have done is I've just calculated the average. I've taken the CL value just because I did not want to deal with long doubles, floating point values. Then I subtracted the minimum from it, minimum from both values, so that the difference between the maximum will get will be remaining. So it can be like this can be dragged down to like max of a comma b minus mean of a comma b, or simply absolute of a minus b. Okay, it can be simplified to this. So I just overcomplicated a bit. Then I am again like taking a CL value after dividing by C, because you can see in this case also the difference will be 17 minus 11.5, that is 6.5. So after dividing by 4, it will take like if I take a general floor value, it will be 2 only, sorry 1 only, but sorry here the cup contains 3 sorry, it will be 2 if I take floor value, but if I take I should take seal value, because it should be 3 only because of the extra operation required here to transfer 1.5 milliliter. So I've taken the seal value here, adding C and subtracting 1, and by dividing by C, and that is the solution for it. Anyone have any doubts? Okay, I guess no. I'll continue with the second question. Okay, in the second question, there is a corridor given that extends to infinitely to the right and divides into square rooms. And the person starts from the first square and proceeds to room number K. And like he wants to maximize the number of K, like the number of rooms he can travel and return back to his initial position, that is the room number 1, and without encountering any trap. And every trap has a sleeping time, like triggering time. Like this trap may be triggered after if he crosses at time 3, this trap maybe get triggered after t plus 100 time or t plus 1000 time. Okay, it depends on the value given. Okay, so what happens if I just cross this trap? Right. Let me see. If I just cross this step at 2 time, like second, I'll be crossing this step on second time, and there is like triggering time of 100. I can just come back to this step after. I can just return back to this like square in between this 100 gap, because it will not be triggered till then. After a trap gets triggered, we cannot like enter or exit a room through through that corridor. Okay, let's just look at some test case. It will be more clear. Okay, here we are given a series of like traps and traps. Okay, I'll just look at it. Okay, we have a trap at second position. Let's see. We have a number line 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have a number line. Then we have trapped at 8 for second position. We have it for it gets triggered at 8 second. Okay, we have a trap at fourth position, that gets triggered at third second. We have a trap at fifth position also. that gets triggered at 2 seconds. Okay. Now let's try to cross like from this position. If I've come from this position to this position, like I'll take 1 second, and this the remaining time for this trap will be 7 seconds after I cross this square. And like if there are no traps, I can just uh travel till it becomes 0 or something like I can travel here. It will become 6 after one after crossing another square. It will become 5 after crossing another square. Now if I return from here, I can like it will take 6. I can cross this square at 6 seconds. I can cross this square at 7 seconds, and I can cross this square at 8 seconds. Okay. You can see that uh this this trap gets triggered before I reach room 2 again, like while returning from this fifth fifth room. This traps gets triggered, so I cannot go to room 5 if I have only one trap. I'll go to till room 4. Then and let's see what happens at the 7th second. Okay, at the 8th second, 6 6 sorry 7. Okay, some mistake. 5 4 5. 4th second I'll cross this room. At the 3rd second I'll cross this room. At the 2nd second I'll cross. Okay. Okay. The remaining time is not 0. Okay. I have crossed this square at 8 second, then 7 6 5 4 3 1 2. So you can see that I can go from here to this 5th square and return from that without encountering any trap, because this trap does not like get triggered, because I've crossed it before that 8 second interval. But if I travel till here, the trap will get triggered, because it will take me around 10 seconds to like go from here to here. So but I have a like triggering time of 8 seconds only possible here. So I cannot cross from here to here if I have a trap of 8 seconds here. Okay. That's for if I have a trap here 2 and given trap here 3. Okay, let's try to cross this one. Just 2 seconds. Okay. Okay. If I go till here, and I can go till here, and if I go till here and return, this trap will get triggered. So I have to return before that only. Okay. The one thing you can notice is that this thing is monotonic, because if I can like travel till here and return from here, and then obviously I can travel till here. Like if I can travel from here to this last trap and return back, then obviously I can travel till here and till, because I'll encounter less traps only. Less traps only. Okay. So okay. Okay, this thing is monitoring. So I what I did the binary search on the value of k. Like I am checking if I can go till this um square and return back here before triggering the trap. Okay, let's look at the code. It will be clear. Okay, let's consider mid as the current K. I'm checking if it is possible or not. Okay, if mid is the current K and I dot F is the triggering time of the trap. Triggering time of the trap. Okay. If I can if the trigger it has a 8 second of triggering time, I guess. Okay. Then what will be the answer? Let's see. If I take 2 here, 2 minus 8, that will be sorry. Let's take a bigger value. Around 4 or something. If I take 4 minus calculate 4 to 8. Okay. That's it. Okay. If I have 5 here and I dot F is I guess 8. If I'm checking if 5 is possible or not, huh? Let's go till this case. What is this? This is 5. Okay, 2, 4. Okay. For this like second trap at the second position. Okay. If I trigger the trap, this how much time I have left till after before I return to that position again. That will be like the value of K till where I am going, because if I am going till here and the trap gets triggered here, I have the remaining gap of 1 index only, and that into 2. I have if I multiply this, because I have to go and return, and that should be the time less than the triggering time of the trap. And this is the index of the trap, and that should be because if I go till here, from this step to this step, I should go from this step to this here. I should be able to go here and return here. So if this is the value of K is still here, the recurring time of the trap should be less than, sorry, greater than this minus difference between these indices. Okay, that is what I've done here. Yeah, I've checked if the remaining time into 2 for returning is less than the triggering time of the time, then I can continue, I can go through that room only. If that is less, then I cannot go through the trap, and it will return false. And the answer will be the maximum possible value. Okay, that will be the value returned by the binary search. Okay, this is question B. I have overcomplicated this also. I guess this has a very nice and better solution. Anyone have better solution for this question?
Yes, I have simply used an iteration using that no binary system. Can
You
show
can
a
explain.
solution to this system.
Okay, I'll stop this.
Yeah. Is my screen visible? Is it visible?
Yes,
Hello?
it is. Yes, the screen is visible.
So my code for P is this much only. So like as you used the binary search, that was the I guess the most intuitive one. But what comes to mind. But what I did was that, like, looking at the question, just a minute. Okay, so if we look at the question, so whatever at like first observation is that since they said like there may be repetition, like the values of I can be repeated. So I made sure that for each of the point, I'm taking the minimum possible time like to cross. Suppose that here at the corridor number 2, at the room number 2, suppose it's given SI value as 5. And later if I'm getting that at room number 2, the SI value was 2, then I'll be taking the 2 value because a person when starting from room 1 and when it will be moving to room K, again it has to come to room 1. So that means like I have to like satisfy the minimum time for each of the room. So in my implementation, I had made sure like if my map it's already present in my map, so I'll be updating my map value with the mean of the already stored value and whatever I'm getting right now, or I'll be simply storing the value in my map. So in this way, I've just stored for each of the rooms what is the condition that I have to satisfy, the corresponding time of triggering. So after that, if we make a note, suppose I am at room number 2, and if as it is given, I'm in room number 2 and my time is s equal to 2. That means if I have to proceed to any further room, it always has to be like I have to come back to again to the room from where I started. So it always has to be in a multiple of 2. Like if I'm currently at room 2 and if I have to go to room 4, that means to come back, I'll need 2 into 2, like the double of the time that I took to go to that particular room. So that's why in my implementation, what I'm taking is that if my current room has got some limitation to satisfy. That means if it is present in my map, I'm updating it with the mean of the answer, like current room, till how much step it can go. It can only do the half of the condition to be satisfied. So in that way, I'm taking the mean of the answer and it satisfies the answer. So that was the implementation for them. Binary search would also work. I found it easy. So I'll continue with the question C. I'm audible, right?
Yes, you can continue
Yeah.
discussing.
So in the problem C, it was a complete math question. So I found it easier to like break the question into some edge cases. So just yeah. So in this question, we had to satisfy two of the conditions given. We are given L and R, the left and the right boundaries of a given, the range is provided to us. We need to find two positive integers A and B. Positive means you have to discard every value less than equal to 0. So your answers A and B should take values from starting from 1 to any upper bound. So also the conditions to satisfy is that whatever integers A and B are taking, the sum should be greater than equal to L and it should be less than equal to R. And also the GCD of A and B not be equal to 1. This condition means that those A and B cannot be co-prime. That means like their GCD must be something greater than 1. They must have a different highest common factor other than 1. So, and if there is no answer, then you need to write that there doesn't exist any answer. That means -1 you have to return. So I found it easier to like break the question into different cases, what can occur. So it's very like, I would like to explain with that. So one of the first case that I've considered is that suppose if my first LNR, if both are prime numbers and if both are equal, that means suppose you are getting L as 23 and R is also 23. So that means both of them are the like their common factors will or they will always be like 1 and the number itself will only be the thing, the highest common factor. So they will never satisfy this condition like GCD of not equal to 1. Like you will not be able to satisfy this two conditions anytime if two prime numbers are given if both are equal. So this will be a -1 condition. Next, I have handled the case when L is equal to 1. I guess like there can be a generalized solution for it, but I found it easier to like handle some of the cases. So like if L is equal to 1, you can just dry run and see that up to 3, like for 1 1 1 2 1 3, there will not exist any answer because you will always find the GCD as 1. So the second condition is never satisfied. But if the value is from 4 to from starting from 4 to any upper bound, then you can always make 4 as the answer as 2 and 2. So the GCD will be 2 and their sum will always be 4. That means you are equating the sum to the right answer. Whatever like 1, 7, 1, 8, 1, 9, you always have this 4 as the sum, which can be broken down into 2 and 2. So this is the case I've handled for L equal to 1. So again, for L equal to 2, if you observe, there won't be any answer for 2, 1, 2, 2, 2, 3. But for 2, 4, again, you can break it down into 2 and 2, and the answer will always exist thereafter. The third case that I have handled is that if my number L is not equal to 2, because 2 I have already handled it above. So if there is any other even number, then I can always equate it. Then I can always make the sum as L, because L is my even number greater than 2. So if it is 6, then I can always make it as 2 and 4. If it is 8, I can always make it as 2 and 6. So the highest common factor will always be 2 and the sum will always be equal to L. So this is one case I've handled. The next that I have handled is that if L is a prime number, we know that there is only one even prime number, that is 2. So and all the other prime numbers are odd. So if L is a prime number, that means the number after that will always be an even number. So I have handled that case too. I have tried to equate the number to L plus 1 in this case. So 2 is the GCD and the sum will be L plus 1. The next case that I've handled is that suppose if my L is an odd number and the other number that I have is either like this number is an odd number and the difference between R and L is greater than 0. That means suppose it is 25 and my R value is either 26. That means it's an even number, or it is some other number like anything, but it is greater than 1. So in that case, I can again equate it always with the even number, because after odd you will get an even number. So that is L plus 1. And the generalized one that I have handled is suppose for the cases like you can say 25 and 25. So in that case, how will you get the thing? So in that case, I have used the divisor thing. For 5, like you can break it into 5 plus 20 to equate it to 25. Suppose you are getting 27, so you can't make it 3 plus 26 like that, because you also need to make sure that. So it was better for me to like go with the divisor thing. So I found out the divisor. This is the basic divisor finding template, I guess you all know. So this is, I'm checking if my I is a current divisor, then I'm finding out what will be the corresponding, like if I'm equating it to L, so what will be the other part, L minus 1. So if the sum that I'm getting is equal to L, then I'm just returning the answer. And the same I'm doing for L by I. So if none of the cases is satisfied, then minus 1 will be the answer. So actually I have broken down into a number of cases, but I don't think they will be needed. If others have any better solution, they can share. But I just broke it down into as many cases as possible. So that was C.
Okay. Raj, you can speak.
Yeah, sure.
Hello, hello. Yeah.
Yeah.
Can you just explain the very first condition for those two prime numbers that you told right now? The very first condition.
This one. Yeah,
The
this
prime
one.
one.
Yeah. So
The
suppose
beginning
like
of the
what
code,
I'm this one. This is the like I'm checking whether a number is prime or not. This is
also
the
if
code of
let's say if both are prime and okay, and both should be equal. Okay, okay.
okay. So you are asking me this one. How is this intuitive?
Yeah, the first.
Should I
Yeah,
explain
the
this?
first.
Okay. Okay.
Yeah,
Okay. Sure.
I got it. L should be equals to R.
Understood.
Okay, okay. Fine.
Yeah. So
Yeah,
because
yeah.
their GCD
Okay.
will always be like the number and that one.
Okay.
But if
This
they
there
would be
is like
distinct, then the
unnecessary
answer is
condition.
possible.
Yeah, I know. I have said that there may be some unnecessary conditions, but like looking at the question, that's just what I know. No, I guess many can be removed. Many cases.
Okay.
If anybody has
It
better
had.
solution, can share.
Okay. It has better solution. Okay. Okay. Also my fault.
Yeah, just show
Okay.
it. I'll stop the share.
Okay. Trilasa,
Hmm.
did you like derive some formulas like show me code? There should be a formula.
Should I share it again?
No, no.
Raj,
Okay.
is your doubt clear? You can. lower your hand, I guess. Do you
Yeah,
have any more
yeah, it's
queries?
clear, it's clear.
Yeah, you can just lower your hand.
No, not for now. Yeah.
Yeah, sure.
Okay, let me explain. Okay. If the first question, first condition is if r is less than equal to 3, then answer is -1 because I cannot achieve like uh, two numbers and two numbers. That's like if I have r equal to 2, I like maximum answer can be a equal to b equal to 1. Is feasible. A equal to 1 and b equal to 1 is not possible because both the GCD of a and b will be 1. Okay, so r equal to 2 is not possible, r equal to 3 is also not possible. Okay, I have just put in -1 when r is less than equal to 3. And for other conditions, like let us consider p is a divisor of like one. Let us consider p is a divisor of x. Like p is a, like okay. The case is if L and R are different, if L and R are different, if L and R are different, there must be an there. Okay, the condition is there must be an even number between what between L and R. Okay, this first condition is I can you guys notice. I guess you can notice because uh because if L and R are different, the L and R can be like at the minimum L will be R will be L plus 1. At the maximum R can be like L plus 2, L plus 3, L plus 4. But at the minimum R will be L plus 1. And if L is odd, R will be even. If R is odd, L will be even. So it is like always be there will be one of these will be even. So answer can be if R is even or if L is even, the answer will be L. If like L, if I consider L is even, answer will be L by 2 and L by 2 because the GCD will be L by 2 and it is finally okay. The sum will be that L only. Okay, this is the first condition. Like you can imagine, and there is a second condition. You can see. Like now the question boils down to look like this: is the city of this sum should be a like I have to just find A and B for L equal to R. Okay. Okay. So the question boils down to L plus A plus B equal to R. I'm considering R because L and R are the same. And B A plus B B R and the city of AB should be greater than R. Okay, the question gets a little simpler. Now I just have to find for these two conditions only. Now I'm considering if like if for this here this equation here, I'm considering like P is the divisor of like GCD of A and B. So A and like A and B P is the divisor of A and B. So this will be A by P plus B by P. Okay, so I'm considering A by P equal to something X plus Y. Let's consider equal to R. Okay, now if like the L and R should we can like the answer will give in the like X and Y should like would not be like very much distant distant apart. So I've considered P equal to P into X plus like Y equal to X plus 1. If I consider X plus 1 equal to R, then the question again boils down to like this X equal to r minus 1 divided by 2 p 2 into p. Okay, so if I know x, I can find a and b, because a by p will be this equation. So a will be r minus 1 divided by 2, and b will be x total sum minus r minus a. And that is what sorry, r minus not r minus 1, r minus p. P is the GCD of A and B. So GCD will be divisor of R only, divisor of R. So I have found out the divisor of R, and if I is the divisor of R, I have found out x R minus P divided by 2, that is x minus I divided by 2, and then B is x minus A if the GCD is greater than A into some conditions to get rid of. Okay. This is all from my part. Okay. Teresa, you can proceed with the question.
I'm not
Hello?
able to open CF. You open the question, I'll explain from there. And then show the code from this one. You
Okay.
open the problem. The screen is stuck. Yes. When you opened it,
Yes.
open
I
the
have opened
question.
it, but okay. Wait, I'll open a solution also. Mm. Okay. This question is a plus minus permutation.
Yeah, open the problem. The back. Yeah. Oops. Um, So basically, in this question, we are given three integers n, x, y. So we need to find the score of the permutation of obviously n, and the condition, the score is defined as p1 dot x and blah blah till x minus p1 till y. So basically, the second line describes what we have to find. The score of a permutation is the sum of pi for all indices I, which is divisible by x, minus the sum of pi for all indices I, which is divisible by y. So what do we need to find is that we need to maximize out of all the permutations possible for length n. We know for length n, like n factorial permutations are possible, the different arrangements that we can do out of it. So out of all, we need to find the maximum score which is achievable by the permutation given it here. Okay, so I guess the question is done. I can explain the code. I'll share my screen now. You can switch off. Stop sharing. So, okay, check out that. Is screen visible? Hello?
Yes, it is visible.
Okay. So I like to like, how can we maximize the score if we just make an observation? So considering my n is equal to 7, okay. So just looking at the general thing, suppose x is equal to 2 and it's given that y is equal to 3. This is the two variables that are given to us, okay, and n is equal to 7. Suppose these are the constants which are given to us. Now, if we just look at like what the question demands from us, if I just take the simplest permutation of all 1, 2, 3, 4, 5, 6, 7. So for the x thing, which of the positions we'll have to consider? We have to consider the index number 2, that is 2 is present. Then I have to take the sum of 2 plus 4, right? Then I have to take 2 plus 4 plus 6 because 2, 4, 6, they are present at the indices which are divisible by 2. Like second index, fourth index, sixth index, and these are the values. So for y, what will be the indexes? It will be 3, the third index, and it will be the sixth index. So what will be the values at that index? It will be 3 plus 6. So what is the score that we are getting in this case? Our score would be, it will be 12 minus 9. That is 3. So in that case, the score that we are getting is 3. But this is not the optimal score. Why? Because what we want is that we need to maximize the score. That means this is the part that we are adding and this is the part that I am subtracting. So in optimal case, my this sum should be as minimum as possible and this sum should be as maximum as possible. So what I can intuitively find out that I'll have to take the three values that I know. Since I know that x equal to 2 and I know n is equal to 7, that means by dividing it like n by x, it will give me like how many positions will be divisible by 2. Like 7 by 2 is 3. So we know that there will be 3 positions available to me that I have to take. Similarly for y, n by y will give you the number of indices that will be divisible by 3. So the optimal thing that we can do is that I can just sort like whatever permutation that I'm considering in the first case. I know that I have to take 3 indices. So what I can do is that I can just take 5, 6, 7, like the from the last, if I just say in the sorted order, I can simply take 7, 6, 5. And also for the minimum, as I need the minimum one, what I can do is that 1 plus 2. One that we have to is that this sixth index, it is divisible by 2 as well as it is divisible by 3. That means in your score, the value of this index won't be considered. Like you will be adding it here and then you will be subtracting it from this sum. That means it nulls down to 0. So we need to consider those indices also, which are, the multiples of both x and y. So in that way, we need to, that's why if you can see in my code, what I have done, this part is giving the number of indices which are divisible by x, but this part is giving the number of indices which are divisible by b. Now, what I have found out in the remaining one is that how many indices are common to both x and y. Like, what are the number of indices which are the multiples of both x and y. So I have divided it by the lowest common multiple of x and y, and I have tried to find out how many indices are common to them. That means those values will not add or like they will be of nothing to the entire score. So we'll have to take that into consideration. Now, if we look at it here, the optimal choice will be that we'll be taking from the last 7, 6. But in that case, now we have got that the number of common between them. That means if I say their common indices, the number of common indices are 1. That is the sixth index. The sixth index is the common to both. That means the value of that won't be subtracted. So what I'll do is that the number of things that I have to consider now will be x will be now equal to, I won't take the 5 thing. I'll take 7 plus 6 and y I'll take only 1. That means I'll reduce the number of intakes for each x and y by the number of common indices because they don't have any contribution to the score. So it won't be optimal for me to take them and like subtract a bigger number from the remaining y. So what I can do is that I have found out the number of common indices, like there are total 1 common index. So I'll be like, instead of taking 3 numbers for x, I'll be taking 3 minus 1, 2 numbers from these like the descending order. If you sort it, then 7, 6, 5, I'll be taking 7, 6. And for 1, I'll be taking only 1. That is 2 minus 1, I'll be taking 1 value. So we know that the sum of the values, like there is a formula n into n plus 1 divided by 2. That will give you the sum up to the n number. So I have just exploited that particular formula only. I have found out how many a now a I have to take. That is a minus equal to n. And as we know, 1, 2, 3, 4, 5, 6, and 7. So how can you get the sum up to 7? Like up to, we know that the sum up to 5 will be equal to 5 into 5 plus 1 divided by 2. And I have taken the entire sum before. As you can see, my entire sum n into n plus 1 divided by 2 is already present. So 7 into 7 plus 1 divided by 2 I have already taken minus this. This is how I'm finding out what is my positive score. That means the score that I have to add. I've just exploited the permutation formula as n into n plus 1 by 2. So this is the sum that I'll be adding. And how to take the subtraction thing? The subtraction thing is in this like sorted order 1, 2, 3, 4, 5. So I can simply exploit the formula by b into b plus 1 divided by 2. And their difference would give you the optimal score. So this is how I've solved the question. Or any videos on equating or any better solution to it.
It's fine. Agraj will explain DN.
Hello. Hello. Hello, Dimple.
Hello, hello.
Hello, Dimple.
Hello, hello.
Am I audible?
Yes, yes.
Dimple, am I visible?
Yes, yes.
Okay. So question number E. Name of the question is data structure fan. Here it is given that you are given an array of integers as well as binary strings, and also and binary strings is given. Here it is given that we have two types of queries. The first query of type 1 consists of two integers apart from the query type L2R. They are basically indices of the array. It is actually referring to a subarray. So what I have to do is we have to just flip off the binary digits of that subarray. If it is 1, we have to convert it to 0. If it is 0, if convert it to 1. And the next query is of type 2, and we have to calculate here is what the byte by XOR of the numbers that are currently in 0, because in 0 and also and of course for the 1 we have to go through the 1. So for example, I will here it's given an example. For example, if n is equal to 4, a is equal to this. So here for for s of I character, this a of I is bounded with it. So for example, if the query of type 2 is given, and it is given that we have to XOR the value of the a which are binded with s but have in the index of 0. For example, it is given that query of type 2 and 0. So here zeros are s of 2 and s of 3, right? So we have to XOR a of 2 and a of 3. 2 and 2 XOR 3 is equal to 1. Also type 1 query here 1 to 3. So we have to take the subquery 1 to 3 and we have to flip the bits. So now the s becomes 0 1 1. So like this we have to consider all of the queries, and for the type for the type 2 we have to print, and for the type 2 we have to make some internal implementation to update it, some kind of. So here the input is normal standard form. First we have given input the size of the array, next the integers, and of course then the binary string. Now the main focus of the question here is not to just do the brute force, because in doing the brute force, right, what we have to do is because if we go to the brute force, the first idea that comes to our mind is we take an L2R, for example. We take for some example for L2R, and we do what? We flip all the bits, like doing the brute forces. But this requires a data structure, but still segmented cannot do it with lazy propagation also. So what we have to do is we have to think of something else that can optimize our solution. Okay. So now, for example, let's see. For example, our array is 1, 2, 3, 4, and 5. So for example, the corresponding is 0, 1, 0, 0, and 0. Right. So I will keep two integer 1, integer 0 for num 0 and num 1. This will take the number. This will keep the current XOR with a value 0. For example, 1 XOR. So 1 XOR 3 XOR 1 XOR 3 XOR 4 XOR 5. Okay, 1 1 1 3 4 5, and 1 here only exists for 2. So now if we have to update, like for example L2R query, right? For example, we have to update this. So now the S will become like 0 0 1 1 0. So now if the container 0 have to be 1 XOR 2 XOR and 5, right? And for the container 1, we have to just keep 3 and 5. Now here is the tricky part. How can we just update it from here to here? We have to update it, right? From here to here, update it. So because it is XOR, let's XOR this one and this one, right? So if we XOR this one, this array and this array, like if we XOR this and this value, so one will cut down, of course, 1 XOR 1 0. Yes, 5 will cut down. It is given the 3 and 4, right? You see the the main value now prime value come 3 and 4 after the updation value, the new value and the old values are, if we XOR the new value and old value, the 3 and 4 will come, which is exactly equal to 3 and 4, right? This. Okay, 3 4 and 2, right? 3 4 and 2. Now here if we update, if we just XOR it, it is 2 3 and 5, again 2 3 2 3 5. Okay, sorry. Yes, it is 3 and 4, sorry, 2 3 4. It's 2 3 4. So what we just find out is that we now have just find out that for each updation we need just from L to R the XOR values in the prime array, the first array that you have given, which you can easily find out using the prefix sum, because if in the prefix sum we want to find an XOR of the subarray, we just have to prefix the, we have to just do what, uh, from L to R. If so, this is L, this is R. So we have to just take the prefix of, and after XOR with prefix of R and prefix of L minus 1, we will be able to find out we are ready to go with the XOR of this part, right? Yes. Now for the solution part, yes, I have used here. I will be using the prefix sum. You can use any of the data structure if you can use segmentary also. So here, so the code is, so here I have to get input, also the strings. It is a one at count the zeros, and then this is the one, the two variable that I have to do, the 1 and zeros. If SFI is equal to 0, then I have to first initialize the values of what are the containers 0 will hold and containers 1 will hold, right? Yes. Then after that, also I have to make the prefix of this one. This is the prefix of value. And for each updations, if it is a query 1, then I have to update it, right? So update it with the, so I have to solve with the first quantity with the updated value with the new zone of the subarray zone, yes, of course, of the subarray zone, then which we have just updated the 1 and 0 zone. Or else we just have to find the index for which query of this type. Like for example, if this query of 2 and 0, so we have to just find the 0 part. If what else we have to just one. This is the solution. Is there any doubt? This one?
No, you can continue with the next question.
This one. Okay. So for the next solution, the next problem is basically kind of implementation and graph problems. So here we are given that we have n elements, right? For n elements, and for each we are given that there are n elements, and for each element there is another element which is ai, which the element is afraid of, and ai is not of course to I. So for the, like for the first element, it will be afraid of some ai, and ai is not of course the, because the cow will not afraid from the same from himself, right? So AI is not easy to type. Also, the cost of each element is given and it is in the C. So basically, we are given two array. The first array with the index, we can find out the value AI, which is the I afraid of, and the cost CI, which will earn if we sell this guy. If we sell it in some order formally, we'll need to some permutation. For example, if it will be in permutation, right? In which order we have to say. So the profit is like calculated in like following properties. Okay. So if we sell the animal I, there will be two possibilities that the AI, the animal that I is afraid of can be sold previous of I or after the I. Okay. If the afraid element is sold previous of I, then we only get CI amount of money that is stated to the I, right? But if the afraid animal was sold after the ith animal, then we get double money for that element. So basically it is given, basically the question essence is, if at the time of selling the afraid element is also not sold yet, for that particular I will get double or else we get none. For example, let's say it is given that A is 3, 4, 4, 1, right? And C is given 3, 4, 5, 6, 7. And the permutation is chosen like 4, 2, 5, 1, 3, right? So basically, it is so this question will become very easy if we think like of graph, right? For example, if we apply that directed graph for 1, 3, because 1 afraid of 3, right? Okay, now 1 is afraid of 3, 2 is afraid of 4, 3 is afraid of 4. Okay, so here 4, for example, 2 is afraid of 4, 3 is also afraid of 4. Yes, 3 is afraid of 4 and 3, 4. 4 is afraid of 1 again. 1 is afraid of 3, 2 is afraid of 4, 3 is afraid of 4, 4 is afraid of 1, and 3 is again, 5 is afraid of 3. 5 is afraid of 3. So if we choose this order 4 to 5, 1, 3, right? So for example, if we first goes to 4 and we want to sell, because 4 now 4 afraid of 1, but 1 is not sold, so we will get a double money. So the first animal is sold 4 and A of I is 1, that is for 4, and A of 4 is 1 which was not sold, so we'll get double the money. So for the fourth element which was 6, we get double, twice money, so we will get 12. Like this we have to continue, and after that we have to find the maximum profit that you can become. Maximum profit that we can get, like this. So now it is given basic input, the number of cows, the total number of cows, then the integers, that means which element, which cow it is afraid of, and uh, it is basically the cost. So basically this question is kind of, you can think this question like in directed. So in this yes, so you can think this question like it directed. So now to approach the solution, we have to first think of a example. Let's see an example like this. Okay. This is a node, right? Some kind of node. This node. Again, I have this, 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 and again this. Let's see some kind of node is given. It is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7, it is 7, So the best part of this question is it is a directed graph, right? And directed graph with the out degree for each element will be 1, of course, हमेशा. Means if for every time the out degree will be 1, means the out degree will be 1 here always. And in degree can be 0 or 1, some element can have or not, but out degree will always be 1, right? So this type of directed graph, like this type of directed graph, have a special property that directed graph some after some iteration, it will always occur a cyclic part. It is always occur a cyclic part. This one is an acyclic part. This is a cyclic part, right? A cyclic part. And this is a cyclic part. So first we want to think. First, I want you to think about the acyclic part, not the cyclic part. Let's see. Let's see. We want to neglect the cyclic part. If somehow we can cut down this part, and we can isolate this part somehow we can isolate this part, then this is just the topological. If we have to find the maximum profit of this, of course we have to write 1, then 2, then again 4. After 1 this will be 3, and this will be 4. kind of this, right? After 2, this 4 will come 1 to 3. So this is basically the topological sort, right? This is topological sort. So for the acyclic part, we can find just the topological sort. We can just find the topological sort. So the first thing is gone. Now for the non-cyclic, so for the cyclic part, right? So what we can do for the cyclic part? So if there is a cycle present, so how can you find it? Let's see, we have currently isolated a cyclic part like this. Um, like this cyclic. Now everyone is connected to everyone, so I have to sacrifice one variable here, one cow, because I have to start somehow, right? If I have to start somehow, that cow, the dependency of the dead cow, because if suppose example this is 1, this is 2, this is 3 and 4, right? Okay, so if I suppose start with this cow, for example start with 2, 3, 4 and 5, right? So for the fifth cow, you see, for the okay, 2, 3, 4, 1, right? So for the one cow, you see, for the one cow, everyone, the dependency of 1 is with 2, right? So 2 is gone here, already gone. So we can only acquire C of 1 here, but we can acquire from C of 2 here, twice of C of 2, twice of C of 3, and twice of C of 4. So I have to sacrifice one for one node. So for the cyclic part, we have to just calculate that, calculate the minimum value, and have to sacrifice that. So the order will be like this. For example, if I have a cyclic part with this like this, if I have cyclic part like this, and it has a cost of like 2, it has a cost of 3, it has a cost of 5, and it has a cost of 1. So I have to do what? I have to make such that 1 will come in last, right? So I can do what? I can have a sequence of 2, 3, 5 and 1. So this will be an optimal for it, because 1 here for 1 only Ci will plus, but for the rest part we can find the twice of them, because of course 1 have to be sacrificed. So we have come to the solution here. So for this cyclic, we have given a cyclic graph, and we have to do what? For this cyclic graph, we have to find it. For the acyclic part, we have to find the topological sort, and for the cyclic part, we want to just find the minimum value. And like for the minimum value, we have to just found the cycle and have to print it. So you see, this part and this part are independent, right? We have to just make sure that after this thing will come. So why not all the acyclic part can come in some time, can come in the last of the array. So in the back of the array, we can finally push the cyclic part of the graph, right? And for the acyclic part, we can just find the topological sort here. So yes, we can find it. And also, for example, if I have find here, okay, now the question arises, how can we do it? So like, how can we approach to the solution, right? For example, you see, if this is a graph, this is a graph. This is a type of graph. So you see, this is a cyclic component. This is a cyclic component. Component is cyclic, right? This component is in cycle, but this component is not in cycle. 1, 2, 3, 4, and 5. So 1 and 2 will not be in cycle, but 3, 4, and 5 will be in cycle. So for example, you see, this is cycle. So 1, 2, and 7 are acyclic, and 3, 4, 3, 4, 5. 3, 4, and 5 are in cycle. So how can we distinguish about it? And so the first problem that arises in this approach is that how can we find a cycle about? So we can find a cycle because in the directed graph. So what we can do is we can keep a visited array, and we can have a integer that is currently with filling. So for example, if now I'm filling with this, so I can make the visited array 1, 1, 1, 1, 1, again 1. So for this index, for the 5th index, for the fifth vertex, if this vertex again find a vertex that is adjacent to it and have a same index like for this current iteration, so it will found that it is a cyclic component. So then thus then we can just backtrack the whole array by keeping a parent array and just finding the whole cycle, right? And also we can somehow, if we find the cycle, we can somehow keep an array like this, and we can allow that array to have it, we can allow the array to make sure that these things are in cycle. So next time when you find topological sorting using BFS algorithm, so if these types of array come which are in cycle, so we just do not allow this elements to continue in the topological sort. So yes, so now for the code. Okay, so for the code, this is yes, this is the first iteration of DFS right here, for example. Now here for my current array, this current array basically hold the terminating cyclic part, right? So for example, now my iteration is filling with number. This number will be unique for every iteration. This is parents. Okay, this is the cost array. This is parents. This is visitor array. This is graph. So for iterating the adjacency list, if the visited is done, means the array is visited. But if it is visited, it cannot be on the cyclic part also. For example, you see this, 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 and this. You see, when we iterate from this index, we'll make sure the visited is like 1. But when we start from here and visited with 2 or 3, then it is still be visited, but it's not in the cycle, right? So make sure that you can handle this case, right? So for this case, I have given an integer like integer. This integer will change up for every iteration. So if in the current iteration it is visited, then we can just identify it. So example, for if it is visited, and if is visited, and also if my visited is my current element. So now the cycle is iterated, right? So what I have to do is we can just iterate through the whole parent, and we can store here somehow the whole current value. We can find the minimum value here. This is up to your implementation. We can find the minimum value, and we can just store the minimum value in a current vector. So this is the basically now for this iteration the cyclic component, the terminating cyclic component. Yes. Or else we can just do what? We can just have DFS. And now if you see here, it is num, right? If we initialize every time the number with even, this number is always even. For example, if you assume that number is even, and when we iterate through the cycle, if the number, we just make sure that the visited in the visited array, we just put num is equal to num plus 1, right? Num plus 1. So now the visited part always have a value with odd if it is in part of the cycle. So here in the topological sort using BFS, what I can do it, we can just start a normal topological sort from the values which have in degree of 0. Okay. So now if for example, if we find out the q dot from, now the current vertex, if for the current vertices the visit part has an odd number, so just we have to we make sure that it does not, we cannot just find out the adjacency of that, and we don't need it, we just continue because it is in the cycle, right? We will just have to make sure that for the topological part we get an order for the acyclic part. Yes. Then again, this is the basic part of the code. This one is the two vector that I have taken input, and after that I have firstly the find out the cyclic part, and after that I have pushed down the values of the topological set. Yes, that is the code. You can just implement the code. I think my implementation is good. Hello, Dimple.
Hello. We
Uh,
can wrap
of
up the
course.
session for today.